Hey kids, this is Mrs. Mooney, and this video is all about function operations and composition. Alright, so we're going to have two functions, f and g. A new function, h, could be made by taking any of the four basic operations, plus, minus, multiply, and divide, and doing them to f and g. Alright, here we go. We're going to do a few examples on these two wonderful functions. F of x equals 8x plus 2, and g of x equals 6x minus 1. So if I wanted to find h of x equals f of x plus g of x, and another way this could be written, by the way, because you might see this somewhere, is they might go f plus g in parentheses and then x like that. Those mean the same thing. And all that means is to take the f function and add it to the g function. So we're going to take 8x plus 2 plus 6x minus 1. And then it's easy peasy, right? You just combine like terms. 8x and 6x is 14x. And plus 2 minus 1 would be plus 1. So our h of x is 14x plus 1. Alright, same f and g. I've just copied them over to this page, but you don't have to do that. It's the same f and g as we just did. Let's find h of x is equal to f of x minus g of x, which could also be written as f minus g of x. Either way, I'm just taking the f function, 8x plus 2, and I am subtracting the g function, 6x minus 1. Now subtraction is a little harder because you have to subtract the whole function. See these parentheses? You gotta have them. I'm not just subtracting 6x and then minus 1. I'm taking, where was I? Okay, so we've got 8x plus 2, and then we have minus 6x, and we have minus 1, which we all know becomes plus 1. So 8x minus 6x is 2x, and plus 2 plus 1 is plus 3. So there's your h of x. h of x equals, there we go, 2x plus 3. Okay, now we're going to take the same two f and g functions, and we're going to do h of x equals f of x times g of x. Or it could be written f times g and then of x. Alright, so my f of x is 8x plus 2. Make sure you put it in parentheses. And I'm going to multiply it by my g of x, which is 6x minus 1. And then, when you're multiplying two binomials, remember you've got to do your fun friend FOIL. So first, 8 times 6 would be 48x squared. Don't forget that little squared. 8x times minus 1 would be minus 8x. Enter, 2 times 6x is plus 12x. And last is 2 times negative 1 minus 2. And then we can combine like terms. Our h of x is 48x squared. Minus 8 and plus 12 would be plus 4x minus 2. Alright, so that takes care of operations. Now, we could also make a new function h by plugging one function into another. And that's called composition. We did talk about this in the last video a little bit when we talked about verifying inverses. If I take f of g of x or g of f of x or something like that, I'm doing a composition. So let's do some harder compositions. We're going to have new f's and g's now. Our f of x will be 2x plus 1. G of x is negative 4x minus 5. Alright, let's find h of x equals f of g of x. This is what we did the other day. Another way this can be written is f circle g. That's not an O, it's a little circle, and then of x. And so what we do is we take the g functions on the inside. So this goes on the inside, and it replaces this x right here. So we've got 2x plus 1 was the f, because that's on the outside. And then we put negative 4x minus 5 on the inside, and then we work that out. 2 times negative 4x would be negative 8x. 2 times negative 5 would be negative 10, and then the plus 1 is separate. So our h of x is negative 8x minus 9. And that's f of g of x. Okay, let's take those same two functions, f and g, and now let's do g of f of x. So we're going to put the g function on the outside. I forget what color it was. Purple today. The g was negative 4x minus 5. And then in place of x, see I put a big open space there because I know I'm going to replace x with the whole f of x function, and that was 2x plus 1. So now I'll multiply that out. Negative 4 times 2x is negative 8x. Negative 4 times 1 is minus 4, and then minus 5. So this g of f of x is negative 8x minus 9. Notice how this is the same as the other one? Please put in your notes. Please, please, please put in your notes. That is a coincidence. Scribble it in there, real big. Not always the same. That just happened to work out that way for this problem. It can happen, like when we did the other day when we were verifying and they both worked out to be x. But a lot of times they're going to work out to be completely different things. That's the norm. Okay, here's the tricky one for you. Now I want to find f of x. And of course that could also be written f circle f of x. That means I'm going to plug the f function into the f function. Remember the f function was 2x plus 1, so I've got 2x plus 1. And then I'm going to plug in 2x plus 1. I'm plugging it into itself. So if I do that math, 2 times 2x is 4x, 2 times 1 is 2. So now that h of x is 4x plus 3. Pretty neat, huh? So lastly, I leave you with a challenge. I want you to try this before you just watch me do it. Find f of g of f of x. We could do any long string of these that we wanted to. Just start with the outermost f. So on the outermost part, I'm going to put the 2x plus 1. I'm just going to leave my x really big because I know I've got a lot to put in there. And then we're going to put the g inside of that. So the g was negative 4x minus 5, so I've got negative 4x minus 5. And then inside that x spot, I'm going to put the f again. So I'm going to put 2x plus 1 in there. And so we need to remember our PEMDAS, and we have to work backwards, so let's go on the, or not backwards, sorry. Go on the inside, innermost parentheses, so we've got negative 8x minus 4. Minus 5, 2, and 1. So that means we've got negative 8x minus 9 on the inside here. Then I can distribute my 2, negative 16x minus 18 plus 1 gives me negative 16x minus 17. And there it is. Woohoo. Alright. And that's it for this video. I hope you guys have a great night, and I'll see you tomorrow.